Hi guys, this is Unit 1, Module 2, Angle Measures and Angle Bisectors. Now, recently we reviewed what points were, what lines were, rays, and line segments. Now we're adding on to our definitions that we use all year. First off, an angle. An angle is formed by two rays with the same endpoint. So if you look at our image below, we actually have two rays. We have ray JK, not JK, and ray LK. You can call them KJ, JK, or Ray, LK, or KL. Remember, the lettering can go both ways. Now, notice how they share the same endpoint, and that is endpoint K. This is what we call a vertex. So they have a common endpoint, which we call as the vertex of this angle. Now, the rays are the sides of these angles. So if we were to actually um, just mark this real quick, this guy's your side, this guy's your side of that angle. Now, if I was to talk about it or note it in a proof, which we do eventually, we would call this angle two things would work, okay? We have angle JKL or angle LKJ. Oops, sorry. Touchscreens can be fidgety. So again, LKJ. Notice how K is in the middle of both names for this angle. That is because K is your vertex. The vertex will always be the middle letter of your naming, okay, of said angle. All right, so your turn number 1, name angle 2 in as many different ways as possible. Just like my previous example, there should be two different ways of calling it. Just remember, find your vertex first, figure out what your sides are, and then just get going on the names. All right, classifying angles. There are 4 types of angles that we talk about, and you'll even hear me talk about it. And angles have a certain degree to them. Now, degrees is a new term, it's a new definition. They're represented by this little guy right here. And degrees are a common measurement unit for circular arcs. If I was to draw on this acute arc, I would draw an arc. It's part of a circle, okay? It's like a circular motion. Now, an acute angle is the smallest of these 4 angles. It is anywhere from it's greater than 0 or less than 90. I like to think of them as like animals sometimes, and this is the smallest of the animals, so it's so cute. Okay, so when you see some little angle like this, an acute angle, it's okay if you're just like, it's so acute. Okay, so just remember it's from 0 to 90 degrees. Now, a right angle is always right. Always right. Always. And it's always at 90 degrees. Okay. Now, an obtuse angle, it's like the big guy in the room. All right. He's way bigger than Mr. Right, and he's not very cute. He's huge. Okay. This guy is greater than 90 degrees, but less than 180 degrees. Now, if you were to fall asleep, you would lay down completely flat. This would be a straight angle, okay, unless you have one of those Tempur-Pedic beds. So 180 degrees is basically just a straight line. And if you think about the connection between a right angle and a straight angle is comprised of two right angles. 90 plus 90 equals 80. Okay, so be aware of that. All right, your turn number 2 with a protractor. Okay, I did a little image down here. I do have them. Just go ahead and grab them. And if you're not sure, I'll help you out and we'll find them. And I want you to draw an acute angle with 23 degrees. Okay, so my example is I'm going to draw one with 53 degrees. So I'm going to line up my protractor on a piece of paper. I'm going to draw my ray. I'm going to line it up. I want to use the inside part of my protractor because I'm right-handed. If you're left-handed, you can use the outside if you really want to do that. I always encourage kids to start here because if you remember fourth quadrant deals. All right, this is 0 degrees. This will be 90. We always start over here. Okay, so it's a good habit for a protractor. All right, so draw your ray. I'm going to go to 53 degrees, which I think is like right around here somewhere. Okay, and then I'm going to try to draw my line. I can move my protractor, so this straight edge right here will go up and it'll line up with my little dot that I made right here. And I'll be able to draw a straight line after I make my dot and I move my protractor. Sorry, touch screen. There we go. And let me make sure it goes all the way through this point Z. And then this will be my angle that's created. This angle will be 53 degrees. And I would call this angle ZXY. Again, my vertex is my middle. Or you can also call it angle YXZ. Either or would work. So try one with 23 degrees. Just draw it and just check with me, okay? Also work with your group partner. Maybe they have a good idea, okay? All right, your turn number 3. With the same protractor, draw an obtuse angle of 115 degrees. So it's like the last your turn, except now you're shooting for a different number, 115. Okay, try to use the inside angles, not the outside ones. All right, definitions. Angle bisector. Basically, an angle bisector just means this. Bi means 2, right? So basically, it's a ray that divides an angle into 2 angles that are both have the same measurement. So if this whole part originally was 40 degrees, okay, and this angle bisector came in, it would break it perfectly in half. So that little guy over there is 20, and this half over here is 20. It's straight down the middle, perfect fold, okay? So these arcs in this figure are shown to have equal angle measurements, all right? That's an angle bisector. All right, postulate 2. So this is our second postulate. It's the angle addition postulate. Basically, all it's saying is yes, we have this big angle here, and we have this little acute angle here. I think they're all acute, okay? There's no right and no obtuse. But if you add the two together, you will get an obtuse angle, okay? It'll be the whole thing. So basically, it's just saying that. Angle PQR, which is this whole guy, okay? Because we're talking about PQ and R, so we're talking about those sides, equals angle PQS, which is PQS, which is this guy right here, plus, let's see if orange works, SQR, which is this guy, okay, and his sides are here. All right, does that make sense? And let me draw you the sides for the green part, PQS. That way you can see kind of the image idea of everything. Okay. So your turn number 4. By using the angle addition postulate, I want you to find angle PQR. So we're still working with the same letters. The only difference is we have to find the whole thing. Okay, so use the angle postulate. You'll get your answer. Should be good. Okay, I think you can do it in your head if you just know the postulate. All right, thank you guys. Have a great day.